Thought for the day. ਇੱਕ ਓੰਕਾਰ ਗੁਰ ਸਤਿਗੁਰ ਕਾ ਜੋ ਸਿੱਖ ਅਖਾਏ ਸੂ ਭਲਕੇ ਉਠ ਹਰ ਨਾਮ ਤੇ ਆਵੇ. One who calls himself a disciple of the Guru, the true Guru, shall rise in the early morning hours and meditate on the Lord's name. ਉਦਮ ਕਰੇ ਭਲਕੇ ਪ੍ਰਭਾਤੀ, ਇਸਨਾਨ ਕਰੇ ਅੰਮ੍ਰਿਤਸਰ ਨਾਵੇ. Upon rising early in the morning, he is to bath and cleanse himself in the pool of nectar. ਉਪਦੇਸੈ ਗੁਰੂ ਹਰ ਹਰ ਜਪ ਜਾਪੈ, ਸਭ ਕਿਲ ਵਿਖ ਪਾਪ ਦੋਖ ਲਹਿ ਜਾਵੇ. Following the instructions of the Guru, he is to chant the name of God. All sins, misdeeds, and negativity shall be erased. Unit 5, Part 2, Colloidal Solution and its Classification. Note: red dot, green dot. Red dot represents solvent and green dot represent the solute. And we have this true solution. Particle size less than 1 nanometer now. We have this suspension now. And particle size is greater than 1000 nanometer, and the topic we will have to study here in this video, that is colloidal solution. The particle size is between 1 to 1000 nanometer. Now let's have the difference between true solution, suspension, and colloidal solution. First is the particle size. We know for true solution the particle size is less than 1 nanometer, and for suspension it is greater than 1000 nanometer, and colloidal solution it is between 1 to 1000 nanometer. External appearance: true solution is clear and homogeneous, suspension is opaque and heterogeneous, and similarly colloidal solution is clear and homogeneous up from outside. Nature of the solution: true solution homogeneous, suspension heterogeneous, and colloidal solution is heterogeneous. Stability: true solution is stable, suspension metastable, colloidal state solution stable. Number of phase systems: true solution one phase system, suspension and colloidal solution two phase system. Visibility under naked eye or light microscope: true solution particle are not visible, suspension visible, but colloidal solution not visible. Visibility under electron microscope: true solution is not visible, particles are not visible, but in case of suspension and colloidal solution particles are visible. Separation by filtration: possible in case of suspension but not possible in case of true solution and colloidal solution. Electrolysis: all these undergo electrolysis. Light penetration: true solution is transparent, suspension is opaque, and colloidal solution is translucent. Tyndall effect: true solution does not exhibit suspension, light can pass, and colloidal solution exhibit. Brownian movement: true solution does not show, suspension may or may not show, and colloidal solution show. Examples: sugar dissolved in water, example of true solution. Starch dissolved in water is a example of colloidal solution, and soil dissolved in water is an example of suspension. Now, in this video, we will just concentrate on colloidal solution and its classification. Colloidal solution in shortly is called colloid, or more shortly is called a sol. A colloid is a heterogeneous system in which one substance is dispersed as a very fine particle in another substance called a dispersion medium. One thing we have to note that for true solution we used two terms, solute and solvent, but here in case of colloidal solution, in place of solute the term dispersed phase will be used here, and for solvent the term dispersion medium is always used. Classification of colloids. Colloids can be classified in three ways. First classification is based on physical state of dispersed phase and dispersion medium. Based on physical state, colloidal solutions are of 8 types as shown in this table, and Second classification is based on interactions between dispersed phase and dispersion medium. Based on interactions, the colloidal solutions are of two types, lyophilic colloid and lyophobic colloids. Very important. And the third one classification is based on the particles of dispersed phase. Based on the particles of dispersed phase, colloidal solutions are of three types, multimolecular colloids, macromolecular colloids, and associated colloids. It's very important also. And classification generally have one question in the examination. Lyophilic colloid, as the name suggests, lyophilic means loving, philic means loving. Colloidal salts directly formed by mixing dispersed phase with the dispersion medium are called lyophilic salts. Example, uh, colloidal solution of gum, gelatin, starch, rubber, etc. These salts can be reconstituted by simply mixing with the dispersion medium. That's why these salts are also called reversible salts. They are liquid loving. And now lyophobic salts, colloidal salts which are not directly formed by mixing dispersed phase with dispersion medium are called lyophobic salts. Example, colloidal salts of metals and their sulfides, etc. These salts can be prepared only by special methods. These salts are readily precipitated or coagulated on addition of small amounts of electrolytes by heating or by shaking and hence are not stable. Further, once precipitated, they do not give back the colloidal solution by simply addition of the dispersion medium. Hence, these salts are also called irreversible salts. Next point, they are liquid heating. It's all about the lyophilic colloids and lyophobic colloids. Now, next classification, that is multimolecular colloid. On dissolution, a large number of atoms or smaller molecule of a substance aggregate together to form species having a size in the colloidal range. The species thus formed are called multimolecular colloids. For example, a gold sol or sulfur sol. The size of single particle is less than 1 nanometer, but size of aggregate lies between 1 to 100, 1 to 1000 nanometer as shown. Here the aggregate of several atom or molecules is formed. Now, macromolecular collide in suitable solvent form solutions in which the size of a micromolecule may be in the colloidal range. Such systems are called macromolecular colloids. These colloids are quite stable and resemble true solution in many respects. Example of natural occurring macromolecules are starch, cellulose, protein, and enzymes. And those of man-made macromolecules are polythene, rayon, polystyrene, synthetic rubber, etc. Here, the size of single particle is between 1 to 1000 nanometer. Here, aggregate will not form. Now, next one is associated colloids. These are some substances which at low concentration behaves as normal strong electrolyte, but at higher concentration exhibit colloidal behavior due to the formation of aggregates. The aggregated particles thus formed are called micelles. These are also known as associated colloids. For example, colloidal solution of detergents or soaps and craft temperature and critical micelle concentration. The formation of micelles takes place only above a particular temperature called craft temperature and above a particular concentration called critical micelle concentration. And note on dilution, these collide revert back to individual ions. Surface active agents such as soaps and synthetic detergents belongs to this class. For soaps, the CMC is 10 raised to power minus 4 to 10 raised to power minus 3 mole per liter. Micelle may contain as many as 100 molecules or more. Now, what is the difference between associated colloid and multimolecular colloid? Both form the aggregate, but in case of associated colloids, they behave as normal strong electrolyte at lower concentration, but at higher concentration, only at higher concentration aggregate are formed. Which is the main difference between associated colloid and multimolecular colloid. Multimolecular colloid cannot behave strong electrolyte at lower concentration. Now, Cleansing action of soap. Soap detergent molecule may be represented as it is the head carboxyl negative portion is shown as pink color, that is stearate ion, and hydrophobic portion is hydrocarbon portion, and hydrophilic part is the negative CO negative or SO3 negative in case of detergent, or CO negative in case of soaps. And in water it form micelle as shown below. Here the simple micelle formation, ionic micelle is formed here. These soaps or detergent in water at higher concentration form micelles, which is shown in the slide with the help of this animation. And the cleansing action of soap is due to the fact that soap molecule form micelle around the oil droplet in such a way that hydrophobic part of the stearate ion is in the oil droplet and hydrophilic part project out of the grease droplet like the crystals. And since the polar groups can interact with the water, the oil droplet surrounded by stearate ion is now pulled in water and removed from the dirty surface. This does soap help in emulsification and washing away of oils and fats. And the negatively charged silt around the globals prevent them from coming together and forming aggregates. It's all about the cleansing action. Thank you for watching this video.